Hi, and welcome to the conference.
Hi, Igor.
Oh,
Hi, Conrad.
Thanks for
hi
joining
Maoni, hi
us.
Igor.
Yeah, it might be a very late evening in your area, Maoni, right?
Um, yeah, it's pretty late, and your voice breaks up a little bit, but we'll see. Hopefully, it gets better.
Yeah, so thanks for joining anyway. And I think since we want to keep a lot of time for questions and answers for later, then let's go straight into the talk time first, and then we'll get back to all the questions.
Sounds great. So, should I start now?
Yes.
All right. So I'll switch to the slides. Can you let me know if you can see the slide? Okay.
Yes, it's perfect.
Awesome. All right. So my name is Maoni Stephen, the architect for .NET Garbage Collector. I've been working on it for a long time, and today we're going to talk about what's new in the .NET 5 Garbage Collector that we just did. So, cool. So before we start, I just want to mention a little bit of doing performance work on a garbage collector. Right. So as many of you probably know that doing a garbage collector for millions of customers is a pretty big task, and to make it work well is even a larger task. So I've had people who ask me, here and there, when are you doing a new GC? So we are doing new GCs, but we also want to improve our existing GCs because we've invested a lot of time in them, right? So in .NET 5, we did a lot of that. We ran a bunch of first party, and we got some feedback from third party customers, and we verified the improvements we got on the GC work that we were doing. So essentially, they focus on two areas. One is improvements on fundamentals. When I say fundamentals, I mean fundamental GC mechanisms, right? So various things we're doing in, various phases, mark phase, plan phase, relocate, compact, or sweep phase. And because most of our customers who have the highest perf requirements are using server GC, so we also did a bunch of work stealing, right? Balance network on various GC threads. So that's very crucial for server GC. I'll dive right in the internal GC improvements. I wanted to clarify a little bit because this is a short talk. I might be mentioning things or concepts that you're not familiar with, but they're all explained in detail in my memory analysis document that I'll have a link for at the end. So I'll share the slides after the talk so you can go there. And in general, for anybody who's doing performance analysis for memory on .NET, I would highly, highly recommend you to go read that doc. I put a lot of effort into it. I think even for seasoned perf engineers, you can still get something useful out of it. So the first one I wanted to talk about is the decommit work. If you're not familiar with the ephemeral segment decommit, we can just like simply put as there's some decommit that we want to do on the ephemeral segment because on one hand, we want to make sure that we keep enough committed after GC, right? Because after GC, your Gen 0 is probably fairly empty, but you don't want to decommit right after the end of Gen 0 at that point because you're going to be allocated right after GC ends, right? So we want to keep enough committed, but we do want to decommit and give that memory back to other processes on the same machine afterwards, right? So at the in .NET 3 X and prior, we were doing this in the stop the world phase of a GC. I mean, I actually wanted to do this for quite some time because there was actually an OS perf bug that would make decommit a lot slower than should be, and that bug has since been fixed. But I was observing some random long GC pauses because of it. So I've been wanting to do this for a while, but we actually got time to do it in .NET 5. Doing a GC work perf item is a lot of work. It's not just about making code changes. It's also you have to test it. You have to test it on the in-house benchmarks and then on the customer's real-world workloads. So basically, what we did was for server GC, because if you think about it, server GC threads are still there when we're done with a block in GC, right? So we could take advantage of that. So we actually moved the decommit work completely outside of the stop the world phase. And we just pick a server GC thread and we would do the decommit in steps, right? Because we don't want to do it all at once, because that would, again, prevent your user memory operations. So we do it in steps. And also we added a better decommit logic, meaning that we have better ways to decide how much to decommit. We also improved this for workstation GC, but of course, workstation GC doesn't really have an extra thread. So we do this still in the stop the world phase, but we try to not do it too much. Okay. So the second one I want to mention is the cart mark stealing. So if we were doing this in person, I would ask you to raise your hand if you know what cart mark or cards are. But since we're not, I'm just gonna explain it briefly. So you can think of cards as the shrink down version of the heap, because we have a generational GC, we're not collecting the whole heap every time we do a GC. So in order to only collect part of the heap, the rest of the heap tells us, which parts of it have references into the parts that we're collecting. So these are represented by cards. So we were observing some imbalance when we're doing the cart marking, and we want to make that a lot more balanced on each server GC thread. So we implemented work stealing. Essentially, we just chunk up the cart table, or the heap, really, because they correspond to their cards. So we chunk it up, and each thread would take a chunk every time. And when you run out of marking the cards on your heap, you would start looking if other heaps still are doing the cart marking. If they are, you're going to be stealing work from them. Of course, because the same code or executes for the relocate phase, so relocate phase automatically get this benefit. Right. The next one is something that some of you probably have heard of, because I did tweet about it. And this was a significant thing for us because this was an external contribution. I would say this is definitely the largest external contribution we got in GC. So Damage Boy, this is his Twitter and GitHub username. So he did this vectorized quick sort. And well, he also did a vectorized biatonic sort, but the main part is the quick sort. So I was talking to him, and so I was interested in using this in the GC because we do sorting. We have a data structure called the mark list. Mark list is something that records objects that actually survived. So this is the optimization that we do. Instead of going through each object during the plan phase where we check, is this object marked or not? We actually just go directly to the mark list. And then we can look at basically only the marked objects, right? Only the survived object. So you could imagine that in order to do this, we do have to sort it first. And we were using the intro sort, which is quick sort for the most part, and then switches to heap sort. And then for the last bits, it sorts it with the insertion sort. This is, if you go to Wikipedia, you'll see like this explained in detail. And I use the smaller font because the other two sorts are, if you have a large data set, most of it would be handled by quick sort. So we used his vectorized quick sort plus the vectorized biatonic sort to sort the last bit. This was based on a paper that talks about if you search for AVX quick sort, I'm sure you'll find it. So this is written by I think a researcher plus somebody from one of the tech companies. So essentially it uses AVX instructions to do the quick sort, so it's able to take advantage of the parallelism in the processor. And we saw great improvements with the sorting speed. So we saw, we could detect that clearly on our first party workloads where we tried this GC change. And even, I think we tried this on the first party workload with AVX2, and we were already seeing, I think in the ephemeral GC sorting, by the way, this is only used in ephemeral GCs because full GCs would just have way too many objects that survive. And I think we saw around 10%, around 7 to 8% in the mean ephemeral GC pause, which is really fantastic. And this was running on the AVX2 machines. If or when they move to AVX 512 machines, machines that support AVX 512, they would see even bigger benefits. So we're very happy with this, and we're very, very appreciative of his contribution. Another one that we did was word memory reset unconditionally. This is a Windows feature, memory manager feature. Essentially, what it does is that instead of when you need to page something out, you're telling the memory manager that these pages contain nothing of importance, so you don't have to write them back to the page file. So we do see the perf benefits of doing this on the memory usage, but we were observing that we did get hit by the page fault costs of this, because that's how this feature is implemented. So we switched to only doing this when memory load is high enough, which really means very high. And in that case, we do need to be very, very careful about paging, whereas we don't need to be as careful when the memory load is not that high. So we also saw this manifested in some first-party workloads that we saw went away with this change. So, of course, the benefit is you don't need to do anything. These will automatically be running when you upgrade to .NET 5. Right. Now let's talk about user-facing features, because these actually do either require you to make some changes in your code, or our library developers to write something in their code, right? So if you're using their libraries, you would be using this feature. I think we already have a couple of places in our libraries that are using this. So I actually just did a talk not long ago that specifically talks about pinning in Conrad's conference. So I have links to the slides and video for that talk. Basically, I'll just reiterate the slides. Actually, this is basically the slide I used there. So this is for situations where you're going to be pinning objects that you allocate, right? So when you're allocating something, if I'm going to be pinning, use these in the pinning situation, then you can use this feature. If that's not the case, then you can't, because the whole point about having a pinned heap is that you have the control of the pinned objects that you allocate. Right. So the benefit of this is they will be staying in their own segments, meaning that they will not pollute the rest of the heap. Right. You will not get into the situations where you have pins all over the place in your normal GC segments. Normal meaning small object heap mostly, and so when we need to do a GC, we can have, these would be right next to each other. So they would already be in a much smaller place than if they were scattered around in the normal heap. And these will be swept in Gen 2 GCs, fairly similar to large object heap, right? Of course, large object heap can be compacted, whereas, pins, they cannot move by definition. However, we, of course, would thread the dead spaces in between live pinned objects on the pinned heap into free lists to use for allocations. In that sense, it's kind of like large object heap when you're not compacting it. All right, so we have, just making sure I'm not running out of time. We have the APIs for the pinned object heap allocations, which are these two APIs that we already had before, but now we just added this pinned parameter. So you can either allocate it through allocate array, which means the memory will be initialized like normal, right? By default, when we hand out objects to you, we always make sure the memory is cleared. And we added a new API called allocate on initialized array in .NET 3. However, I don't believe we made it public until .NET 5, or maybe we did make it public in .NET 3, but I'm kind of losing track there. But in any case, if you upgrade to .NET 5, you'll get these two as normal public APIs, and you can tell them to allocate an object on the POH by setting the pinned parameter to true. I should mention that if you are familiar with how pinned GC handles work, you know that you cannot have references in the objects that you point the pinned handle at, right? It's the same idea here. So the array that you're allocating here, they cannot contain references, meaning that T itself cannot be a reference type, or if T is a value type, then it cannot contain any references in it, right? If you do this, then you'll see an exception. So some of you might be familiar with the hard limit configs that I added in 3.0, .NET Core 3.0. So it was added for the container scenario. So there's two hard limit configs. One is just called GC heap hard limit. The other one is called GC heap hard limit %. Right. So the first one would allow you to specify an absolute number as a limit, whereas the second one will allow you to specify the percentage of the total memory that you want to use for your container. So this is related to POH that we just talked about. We have separated configs for these that allow you to specify the limit per type of heap, right? Type meaning either small or large or pinned object heap. The reason we did this, well, first of all, it's just because the customers that there's not a whole lot of customers that would care about this, but there's a set of customers who are really want to be in control of how much they want to allocate on each type of heap. So another reason was because pinned object heap is, in general, especially if you look at large server apps, they are in general way smaller than the other two heaps, right? So you do want to not have, like, if you don't specify them separately, then GC can't really know, like, we can't predict how much you'll be allocating on each type of heap, right? So for this set of customers, they want to be able to say, like, okay, I know I'm not allocating anything on POH, so I'm just going to set it to 0 or set it to a very small number. Another reason for doing this is because of our customers who want to use large pages, right? So if you imagine, I have a 1 gig large page and my POH is probably going to be, I don't know, 2 megs. So I wouldn't want to waste a large page, a whole large page on POH. Right. So another one I want to talk about is Diagnostics API. So this is something that I'm very happy that we were able to add, because I'm already seeing really good benefits that you can't easily obtain via other ways from our customers. So there was an API called Get GC Memory Info that we added in 3.0, but I would say we're not very we just added it because our library folks wanted to get some info of the GC. So mostly it's just stuff that they wanted at the time. This was using array pool to mostly get like memory load and available by its what is the total memory that GC is allowed to use, that kind of thing. So I have a blog article that I just wrote literally a few days ago that talks about the updated API that came out in 5.0. So when we started 5.0, I had a couple of customers who came to me and wanted to monitor more things, right? So instead of adding a little bit of info that the customers asked for in each release, I thought about, like, what are the common things or the most beneficial things that we should provide per GC that we can give to customers that would allow you to have great flexibility to monitor what you want about the GC, right? So of course, because this is an API, you call it improg, which can be a real convenience, right? For some folks that might not be, because they just don't really want to do improg monitoring. But I know a lot of people do want to do improg monitoring, and it's very convenient to do, right? You just write some code. Basically, you can start your timer before your request. Afterwards, you count how much time the request took, and if this is this appears to be an interesting request, which usually means like is it too long, or is it in kind of a tail latency range? Then you want to call this API to get the GC info out of that, to know whether a GC has happened during that time, right? So this is ties to the tail latency monitoring that I talked in a lot of detail in my memory document, because I feel like this is an area that diagnostics is really missing. I always hear people say that, okay, like our P95 latency changed, but we're not sure exactly why. We can make a guess, but is it because of the GC? Is it because of network IO? Is it because of something else? So at least I'm providing something to them. I identify whether it's because of the GC, and even more importantly, if GC is contributing to it, how much does it contribute to it, right? So it's very common that we make a GC change, right, where we optimize something in the GC. So you try out that change on your servers. You may not see that your P95 latency reduced, right? We can look at the GC data. We can look at your data. Your data might say like P95 did not change, but our data showed that GC perf did improve. So what happens, right? Because other factors that were contributing to maybe your higher tail latencies now are in your P95 range. So that means your P95 doesn't change, but the GC impact would be smaller. So this is very important. So I really like it because we don't do guessing work anymore, right? And not to mention for this API is this is for both sampling and diagnostics, right? So previously we provided perf counters, which were basically just for monitoring. But I want this one to be able to be used for diagnostics as well. So that's for this API. And the link there is the link to my blog article. So I recommend you to go take a look if you're interested in doing GC related monitoring and diagnostics. Right, so I basically just listed what's new in .NET 5 that was provided by this API. I'm not going to go through them one by one. Hopefully that most of these look very like they're self-explanatory to you, because they're fairly familiar things. And I see the last line was cut off, but I have a link to the actual class in my blog article, so you can go read that. Oh, I should probably mention like a couple of things. There's a detailed pause durations, which is very useful to get, obviously, right? And this is, so I provided two things related to pause, because I know that's something that many people care about a lot, right? So I have detailed pause durations for each GC that you get back with this API. And then I also have a cumulative % pause time in GC, right? Because one of the biggest problems with perf counters was perf counter values were updated at the end of each GC, which means unless you're monitoring very closely on your servers, meaning that your interval is small enough, you're kind of at the mercy of luck, right? You just catch whatever GC that happened at the end of that interval that wrote to the perf counter. So this would give you a much better global view of, in general, how much I'm spending in the % pause time in GC. So I think that's that should take care of the pause diagnostics really well. So the last thing I wanted to mention is, last thing is what we call the generational aware tooling. This is kind of, it seems a little odd to me. So about it, .NET GC has been a generational GC since we shipped it in V1. So if you are looking at a generational GC, you think that we should have some tooling that is generational aware, right? Because as I explained in the document, that how important it is to realize that it doesn't do full GCs all the time, right? When people look at the memory usage on a GC heap, they would look at, I still see many people are doing something like, I'll just take a look at a random point in time, and then I'll take another look at another random point in time. I'll just compare the usage, see how they differ. But if you think about it, maybe you're looking at the first random point in time, you're looking at the heap is when you had just done a full compacting GC. Whereas the second random point, maybe you have been running for a while and no compacting GC has been done. Your heap is a much larger size than it was in the first time that you looked at. But that's completely by design, right? It's not necessarily a memory leak in that case. So I explained the generational aspect of the GC, or rather of your GC heap, in very much detail in the document. So please go take a read on that. And I've listed the three generational analysis configs that we added. Basically, based on my past experience in using this on customer workloads, that you generally want to look out for GCs that are really they're not ordinary GCs, right? What I mean by that is, like, let's say you're doing mostly ephemeral GCs, right? Hopefully that's what you're doing, and you keep doing them and use maybe a bunch of Gen zeros and Gen 1 and another batch of Gen zeros and then Gen 1, that sort of thing. And in general, you'll see that let's say you're looking at Gen 0 GCs, or I'll use Gen 1 as an example just because I have it as 1 here. So you look at a bunch of Gen 1 GCs. In general, if your workload is very regular, you should see them promoting or surviving very similar amounts in bytes, right? If you look at the in Purview, I mean, I turn Purview terms just because that's a tool that I use quite a bit. In the survived column, you'll see like how many bytes survived for this GC. So in general, that should be fairly regular. But what if, let's say, usually I see a bunch of Gen 1s that survive very little, but suddenly I see some, one Gen 1 or a couple of Gen 1s that survive a lot more. It turned out that this is often because people either forgot to remove or set some fields in their static objects to null. They have static objects for monitoring purpose, and they forgot to set it to null. And so, of course, GC would view them as live because they're pointed to by a static object. So you can use this feature to say that, let's say I set generation to Gen 1, and then I set analysis bias to this numbers that, 256K or whatever is in hex. As you know, there are complex variables are all in hex. So you can say like, I set, you can set the index to 10, which means that you don't want to start monitoring at the very first GC, because as you know that in general, when you start running, you often allocate a bunch of static objects, right? So of course, the first GCs, they would survive a lot by design. So you want to wait until you're a ways in when you know that you're already in a steady state to set this. So these variables are essentially saying that I want to detect a Gen 1 GC that promoted at least this many bytes, and its index is at least 10. Then what we do is we would take a GC dump at that point. This is the same GC dump that we use the ETW data, or events data, right? Because ETW doesn't work on Linux, and this does work on Linux. And then you can use Purview on Windows to analyze this dump. Optionally, you can also set this event pipe config, which just means that you want to have a big enough buffer to write this dump to, because this could be quite large, right? Because you're capturing essentially the whole heap. I mean, it's going to be much smaller than the whole heap, hopefully, but you want to, I think the circular MB default is quite a bit smaller than 800 in hex. So you can set that just to make sure that you don't miss anything. I'll show you a screenshot here. So for folks that have seen what it looks like to open a GC dump in Purview, right? This is from the Purview tool, which I also mention a lot in my doc. So please go, if you haven't used it, please go read it in the doc. So as you can see that instead of just showing like root, various kinds of root, now you're seeing this category that we call the .NET generation aware roots. and that will tell you like this Gen 2 object, which is called desktop workspace dot inner holder, that points to this object, which is called workspace dot list node, and points to a byte array. So this tells you that the important things that when you're doing a Gen 0 GC, right, you could see like Gen 2 pointing to Gen 1 as well. So you have a Gen 2 object, and that points to a Gen 0 object. Of course, this means that as long as you're not doing a Gen 2 GC, this Gen 0 object will always survive, unless, of course, you replace it by something, right? So so this is what you will get from that generational aware analysis, which personally we have used to find some really useful culprit to perf problems that we have been debugging for our customers. And that is all I wanted to talk about today. Here are some links that you can, this is a memory document that I mentioned. And of course, you can ask me questions on Twitter. Many people have, and I just wanted to mention that the response time may be inconsistent because I don't necessarily look at Twitter all the time. And if you do have perf issues that you'd like us to help you debug, I would actually suggest you to file an issue, because it's kind of painful on Twitter to ask you for dump or a GC dump and whatnot. And of course, there's Conrad's book, which most of you may already have. So that's all. Then we are in the Q&A session.
Yes, thank you, Maoni, for the great talk and a lot of insights into what's been doing in the .NET 5 and what will be happening probably in the future. So a small addition to what you mentioned the person who did this external contribution for the mark table sorting, and it was Dan Schechter, and he actually gave a talk a year ago here at .next with all the details about this sorting. Strange, crazy sorting things using AVX and everything. So if you are interested, then you can go and look and check this talk in our archive and see all the details. Although I think the garbage collector now has the improved version of what we've seen a year ago. So now to the questions, and I think I would like to start with this, the first one about this diagnostics thing. So you said that this new get GC information thing is helping to make more like self-diagnosing apps, so that an application can now understand what's happening in the garbage collection. Fine, but the question is it only for like some logging, so that the external people then can see how the application can correlate like requests to this garbage collection information, or there is a way for the application to somehow adapt the behavior depending on what this information, what garbage collection information it gets? So do you have any examples of the kind of self-adapting applications?
Well, I mean, you can, so think of it this way, like, can you do any kind of adaptation now when you detect some behavior in GC changed, right? You can do basically the same thing, right? You call it in your process. You can call, you can look at various fields depending on what you want to monitor, right? And then if you say like, okay, I detected Gen 2 GC and I look at its promoted bytes, right? And I think it's much higher than what I want it to be, right? So you could then say something like, I know I have a big cache. I'm just going to drop a bunch of entries in the cache. So next time I do a Gen 2 GC, I will see a much smaller survived bytes, right? You could do that. It's the same idea. I don't think that, like, the main thing is, like, I believe that improg makes it very convenient because you can correlate with your code directly, right? Whereas if you do out of prog monitoring or something that's very async, right? Like, for example, events are async, right? ETW is async. You don't get it right away. You get it at some point after. So with the API, you can say like, in my code, I just detect it right away. So I think that makes things easier.
Okay, thank you. And also, you also mentioned the thing about that the, the popular approach is to like, okay, I'm taking a look at my memory dump at some random point of time, then I do it at some another random point of time, and then I try to compare, and who knows when the garbage collector has happened before, or if it happened at all. And the
Right.
like the popular, or maybe not that popular, but the code that I see sometimes in the real code is that people tend to sometimes call the GC collect explicitly, and then like, okay, now we know that our code called GC collect here, and then this is the time we can safely take a dump, and then we compare like right after the GC collect. So does it help anything, or calling GC collect is like a no-go, never do this?
Collect, there's really only two cases that you want to call it. Of course, I should prefix it by saying that with perf, there's nothing that's 100%, right? So there you can always have exceptions. So I'm talking in sort of general terms. Generally, there's two cases that you want to call GC collect. One is like what you said, but you only do it in your test environment. And people do that very often. That's a perfectly valid approach. You could just, in your test, you can say like after some iterations that I, or this many number requests, I'm going to do a gc.collect. Some people would do it, collecting Gen 2, or, you just call GC collect by default, it'll collect Gen 2. And then they would measure, they would call something like get total bytes, right? GC.get total bytes. That would tell them like how many bytes are left on the heap, not including the free space. So you can definitely do that as a totally valid approach. In fact, that I know many teams are doing. Another case is if you're on production, and if you know that you're going to get into a phase that you don't mind the pause, right? I've had people who write trading applications that they know that after the market closes or before the market opens, they don't care about the pause. They can do as many long GCs or however they want to do it. It's fine. So they just do that. I know teams that do that like either right before the market opens or right after it closes. That's fine. Another example of that is like Incompilers, right? If you're writing compiler in managed code, you know that in compilers each phases have very distinct survival characteristics, because after this phase, that everything there is just no longer there. I know that. So you can call gc.collect. That's also valid. But in normal server applications, that is, where you don't have the luxury to say like, I don't care about pauses anymore. Like I'm not taking workload right now. Then it's very hard to justify calling gc.collect, especially if you're only doing this just to diagnose, right? And I would suggest you find better ways to diagnose things. For example, using the new API, or you can take a perf trace that tells you when the GC actually happened, and you can look at its before and after and compare those GCs together. That would be perfectly valid.
Okay, thank you. And the related question is there a way, suppose we are in the test environment, so is there a way for me to trigger a garbage collector, so something similar to if I call the GC collect from the code, but externally to my application? So I know I can probably do that with debugger, but...
Sorry, I'm coughing a little bit. You can also do this with profiler. So if you look at Perfview source, it's public, right? It's at GitHub, Microsoft Perfview. So Perfview actually does this exact thing. So you can, in Perfview, you can say, trigger a full GC in this process for me. And then, it will take a GC dump for you. So like that's after it gets rid of as much garbage as it can. So you can definitely do this. If you look up like iCore profiler, there's a garbage collect method on it. Mm-hmm. So I can't seem to switch away from this Zoom window. So otherwise I can show you like exactly which file in Perfview. But I think it'll be pretty obvious for you to find it.
Okay.
You can search for garbage collect in the Perfview source. So.
Thank you. Conrad, do you have anything on your end?
Yes, a lot of questions in my mind. Obviously, GC is so huge topic. I have one question, for example, about the purview that you, Maoni, have shown this generational aware analysis in purview, because you have shown us the purview showing it, but whether we will see it always or only in the GC dumps taken when those COM plus flags were enabled, or maybe it is just a general
Only
feature
when
in.
those,
Okay.
yeah.
So the GC dump taken during those flags being enabled are a little bit different, so the purview will be able to analyze it and show us all those.
I think I don't think we disallow this when you don't take a dump that way. Like if you just give it an ordinary GC dump that you took, it should be able to display you something as well. It's just that it's not what you would see necessarily in the actual GC, right? Like let's say you just took it at some random point in time, and you could still see like the analysis in purview. I don't believe that it can even distinguish like okay, like this dump was taken because you set this environment variable, or this dump was taken because you use some other like .NET trace could also do it. It'll display you something always. But if you want to actually compare, like when GC tells me that Sunlight had a Gen 1 GC that survived this many bytes, and I want to analyze that, then you should be setting those variables.
Sure.
Does that make sense?
Awesome. For me, perfectly right.
Thank you. We have a question from the chat. So to mark object references fast and correctly, the runtime forbids overlapping of reference types and value types fields. So you cannot overlap them in the structure or anything. Has the C# language team requested any easing up on that restriction? For example, to support compact representation for proposed discriminant union types. So it's like, yeah, any restrictions of the reference and value types, and can you combine them in the same memory on top of each other to support discriminated union types?
I don't really understand the question. Is the question asking that can you have memory with both reference and value types? Or
yes, so the discriminated union in some languages is that the same memory region keeps like either the pointers to some reference types or some integer value, or you can have Boolean or string reference or something. And then on the language
not that
level,
I'm aware.
Okay.
Yeah, not that I'm aware. I have never heard such a request from a language folks.
Okay, so then we will go back to the Mads Torgerson later.
For that, you probably want to ask like Jared Carson, he's our Roslyn lead. So he's a lot more proficient at language designs than me.
Okay, thank you. Talking about garbage collectors, I think that's a pretty popular question, and you should already have a good answer for that. But still, if we compare Rust to the Java world, so in the Java world, we have like, I don't know how many, 3, 5, 10 different kind of garbage collectors. And we know that .NET garbage collector, as you mentioned, tries to be like an optimal in many cases and adapt itself to many different workloads. But the Java garbage collectors, they also develop fast and each in its own like direction. So we have this new, fairly new Shenandoah garbage collection, which I think was included now into the official GDK and things like that. So it tries to do some more, performing more garbage collection work concurrently with the running. So could we compare .NET one to the different kind of Java ones? And if it like,
so Shenandoah is a concurrent compacting collector, right? Which we currently don't have. So, but we're working on one, right? We are always going that way. I mean, Java has a lot more people on GC, first of all. Java has many, many times more people work on various Java collectors than .NET. So, and I also wanted to clarify that when we say that we want to be optimal, we definitely want to be optimal, right? But it doesn't mean that we only have one kind of GC. When we say we want to be optimal for many, many kinds of workloads, what I meant by that is I would like our users to not have to worry about very internal knowledge of a GC in order to know how to run a GC, right? In other words, like if you notice like the configs that RGC provides, they're in general, they don't really require you to know much about what a garbage collector actually works, right? You don't have to know like, oh, okay, like if we have, in the old generation, and when the free list looks sort of like this, then GC will probably tune itself like this. So maybe I want to change that. So we don't want you to have that kind of knowledge. Right? We think that we're getting paid to do that, then we should do a good job on it. But .NET does have multiple different kinds of GCs, right? We have a parallel GC, right, which is a server GC. It's kind of like the parallel GC in Java. We have a background GC, right, which is concurrent GC. So there's multiple flavors of the GC, but it's true that we don't have as many kinds of GC as the Java world does. I should also point out is I noticed that many people have the tendency to say like, I hit a perf problem, right? I think it's related to memory. Often may not even be related to memory. And do you have this kind of GC that I heard about in Java or in some other world? Mostly is in Java, because I think Java definitely has the most number of GCs, right? Are you going to have that kind of GC? But then we look at their perf problem. They usually can be solved by either them making small changes in their code or just give GC some simple configs, and then they can fix it to their satisfaction. So I would say like the innate, you might have to resist your innate reaction, which is like, do you have this flavor of GC instead of like, I have a perf problem. Let's take a perf trace and just take a look at what the problem is actually there. So in my experience, there's definitely some customers, I would say that it's not a large number, that they do have perf requirements that could only be achieved by a concurrent compacting GC. But if you look at the majority customers that .NET has, I don't believe the majority of them require concurrent compacting GC, right? Which does include a lot of the costs that you have to pay in order to use this GC, right? So.
Okay, thank you. And you also mentioned now that GC do have some settings or like knobs that customers can adjust.
Configs.
Configs. And when I was doing the C++ development back some years ago, I used the tool called gflags a lot to enable different kind of heap analysis and things like that. So, and now in the .NET world, it's just a fairly huge list of different kind of environment variables which you need to look for in the source code, or you have been told about them by the runtime team. So any plans to like do some kind of tooling, maybe only in SDK or some very limited tooling like Perfview, to be able to turn these configs somehow?
Well, so I think I'm hearing kind of two different issues. One is, how can you know about these configs? And there are very clearly, almost all of them, I wouldn't say all of them, almost all of them are clearly documented actually in our doc page, right? If you search for .NET Core GC config, you'll see it, no question. So they are documented. You don't have to talk to the runtime. We don't have the kind of scale to have every of our customers. We have a lot of customers, right? To have all of them talking to us, right? They are documented. So please go read that page. And I worked with our UE folks on it. We separated it into different sections. So it's not just like a list of 20 configs we have. It's based on areas that you're interested in. So if you're interested in more like heap control, there's a section for that. If you're interested in tuning like server GC, like with the how many heaps it has, that kind of thing, there's a section for that. So it's already, I would recommend you to go there and take a look first before concluding that they're not, like, you have to talk to us. Our goal for documenting these is not only do we tell you about them, we also explain to you like when or under what circumstances that you would want to use one of these configs. I mean, for a lot of people, they never need to use any configs, but if you do, right, I mean, completely understandable. Like if you're if you're writing a hyper server app, you might want to do some kind of configuration. So I would recommend it to go look at that page. So I think another thing I heard was, could some tooling automatically turn the various configs on when they're appropriate? So currently we don't have such tooling, but we're definitely, that's something I want to work on. So for the past few months, I've been involved with the Visual Studio profiling folks to help them adding, sort of more, memory tools that based on just my sort of years of experience of, debugging things for people, debugging perf problems for people. So as a result of that, they definitely wanted to do something that's very, that makes things more automatic for you. So instead of, if you tell it like, express your perf tuning goal to it, you could say like, for me, keeping the small memory footprint is the most important. Then we can tell you like, these are the configs that you can turn on to reduce the memory footprint. Or, I imagine we could even say like, it can even have an option that says like, would you like us to turn this on for you, right? So that can totally be designed for the tool. So that's definitely something that we're going, the direction that we're going.
Okay, thank you. Conrad?
I have a question about the future, because you have shown us .NET 5, and probably you are now pretty happy with the deployment, and you probably have started implementing or at least planning something in .NET 6. So could you share with us any, I don't know, interesting leaks about what will be changed in the GC area? Do you plan to change something fundamental or another iterative improvements?
Yeah. Yeah, so we are definitely, for .NET 6, I kind of want it to be focusing on long lead work, meaning that we want to change something fundamental in the GC. So the first fundamental change that we're working on right now, so I actually have a PR out right now that's almost to the point to be merged. So we want to change the segments that we're using in GC right now to regions. The fundamental difference between segments and regions is that regions are much smaller units, which means that you can freely exchange spaces between different generations. So right now with segments, right? So we have the segments are much larger range in the virtual address space. So of course we did segments because segments was providing huge amount of benefits for us, right? When we started and as we saw it through the years. So, but we're at the point where it became fairly clear to me that we really need a way to be able to freely exchange, spaces between different generations in order to enable a lot of the other optimizations. So for example, I actually did a tuning for background GC, for a much more optimal way to trigger background GC. However, because it's hard to exchange free spaces between Gen 2 and large object heap, it means that, if I do have a large free object in Gen 2, it's hard for me without doing a compacting GC to repurpose that space to allocate a large object, right? And we don't want to do full compacting GCs, really ever. So that was a big problem. That was what prevented me from really telling you guys about this tuning thing, because I really want to make it work better with the regions before we advertise to our users. So, things like that. And it would, regions, of course, has its own quirks, right? For example, you no longer have a contiguous range for ephemeral generations anymore per heap. So in order to check for that, you'd have to check the regions, basically the region data structure that keeps like what generation this region's in, right? There's a list of things that we keep per region, like generation number is one of them. So that's a fundamental change that we're working on for .NET 6, and I envision this will enable many optimizations that we either were wanting to do or we are planning to do.
So that sounds an awesome thing that will invalidate a lot of pages in my book. At least I will need to add some new ones. For sure, I will
Gives you
contact
some
you
motivation
regarding
to
that.
have a new edition. Right?
Thank you for doing that. And so
Thank you.
so it is much more granular control over the reusage of memory. In fact, like you don't have these huge
Yes.
memory regions, but small granular pieces of memory. Is it that direction that will be helpful for you also in the concurrent compacting things, that you will be able, for example,
Absolutely.
to concurrently compact these small
Yep.
regions? Awesome.
Yeah, so this really just builds, like I said, it does, essentially there's two aspects that we want to improve by doing regions. One is to improve our existing GCs, right? So this will naturally improve our existing GCs because of the repurposing that I've been talking about. And it allows for much greater flexibility in GC tuning. So for example, right now, I have an optimization that says, in my pinning talk, I talked a lot about demotion of pinned plugs, right? So one of the things I did for pinned plug tuning was that I detect if you do have a large pinned plug, that I would then say like this will not be demoted, right? So right now it's very hard to only not demote that one, because as soon as you say I'm not going to demote this one, now this guy will live in Gen 0, then basically everything after that will be in Gen 0 as well, right? So we can't really say, because they're pinned, it means we can't move them. So we can't really make this pin plug and the ones come after it be in different generations. But with the regions, we can say like, oh, well, this region has large pin plugs, so let's not demote them. So they'll go to Gen 1. But this other region has no large pin plugs, we'll just demote them. So that makes it way more flexible. So that's what makes this also very attractive, because we just naturally get a lot of benefit out of it. Then of course this will build a very solid foundation for the new GCs that we want to do. For example, concurrent compacting GC.
Yeah, and we have an extra question about this concurrent compacting GC in the future. So do you mean some new specific GC flavor for paying performance penalty for short stop the world pauses, or optimization of existing flavors? Like we now have the workstation and server, and then we will have background yet another thing, or it will be just an optimization for existing ones?
I mean a new GC. So concurrent compacting is something that would require a read barrier, which we currently don't have, right? We only have a write barrier in our system. So that's something that would be a new flavor of GC, not just as optimizations to existing. Well, we always have plans to optimize our existing GCs, right? As I said in the very beginning. So things like optimizing when you would trigger a background GC. That's an example of like how to make the current GCs work better.
Thank you. And now that you're talking about read and write barriers and other things, so now that the .NET became cross-platform, and I believe the first versions of the GC were highly tailored to the fact that you're running on Windows with all the virtual memory management that Windows has. And so were there any issues, troubles, and interesting things you need to take care of while porting to Linux and macOS, which has, I assume, a little bit different memory management model?
Yes, they can be very different in certain areas of the memory manager implementation. So I actually wrote about this when we first started porting in one of my blog entries. I think the title was something like working through things on other OSs. So I listed a couple of examples. The largest thing that we had to do for porting was that Windows had a OS feature called the write watch, right? Write watch is something that you can set on set of pages, and you can say, let me know when these pages were modified, right? You call an API, it's very nice. You call this API, it'll just tell you like out of the 100 pages you watched, here's the index of 50 of them that were modified. So we use this feature to actually implement our concurrent flavor, because in concurrent GCs, you have to watch out for heap modification while the GC is running concurrently with the user threads. So because Linux sort of has something kind of like this, but it was not implemented completely functionally sufficient for our usage, right? And perf as well. So basically, it has something that would, first of all, it had a very small default of how many mappings you could have in a process, which was not nearly enough for us. And we don't want to ask our customers, like, if you're running on Linux, you have to do this in order to run your slightly larger workload, right? And then we looked into some other features that are just there's and that was sufficient enough for us to use. I believe that some folks in Red Hat did tell me that they wanted to implement something like the WriteWatch that Windows has, but I'm not sure. What we did was like we just implemented sort of our own recording. When you write to a object reference field, we would just record like what page that object is on that time. So we just essentially did our own, which works just fine. So in fact, it worked so well that I actually switched the Windows the Windows WriteWatch usage to that one, because there's pros and cons for doing your own versus using the OS feature. Doing your own has a big benefit, which is you only need to record pages that are interesting to you that got modified. In our case, that means only when you're writing to object reference fields would we want to record this modification. Whereas with the OS feature, WriteWatch feature, of course, you're getting any page that was modified in any way, right? If a page only contained objects with integer fields, you would still get that page. Then, of course, you would go to that page and look for objects, and you would see then like, okay, there's no references on this page, but you have to do the work to figure out, right? So it turned out that the OS WriteWatch implementation also has some perf problems that as we are running on larger and larger workloads, that this just became more and more a problem. So in the end, I think this probably happened like a couple of years ago. I just switched our Windows WriteWatch usage to CLR's own recording. So that's one thing. There's a couple of other things that works differently on Linux versus on Windows, but this was the largest one. Of course, Linux also has features that Windows doesn't really have. I mean, I haven't personally, I've been meaning to set aside some time to just experiment with these, but I haven't gotten there just yet. Hopefully very soon. I'd like to try out remapping to see, like how performant it is, how suitable it is for GC usage. So there's definitely different strengths coming from different OS's memory managers. Yep.
Thank you. Konrad, do you have something on your end?
Yes, I would like to return to those, as you call it, regions for a moment, because having regions, now it is so tempting to expose something which is called arenas, to expose it as a API to the language, so you will be able to, it is pretty low level stuff existing in some environments, so you will be able to say that this object and a bunch of the objects that I will create will be created in this particular region, and then you can just discard this region. So it is called arena, or it has various names. So
yes.
Do you plan to?
So yes,
do you
like arena, I can talk about that. Yeah. So we did actually try the arena feature, right, internally. This happened with the full framework, so this was not open source. And plus, this was an experiment. So the perf issue that they hit with arenas was that because our framework doesn't really prevent you from, assigning to pretty much any objects fields, what they discovered was that they always observed a fair amount of what they call leak from the normal GC heap, the pointing into arenas, right? So ideally, when you have the arena feature, you want the users to be able to say, like, I'm using this arena, I'm telling you, GC, that after I'm done with this one object, all its, the object graph it holds onto should be dead. Unfortunately, GC cannot trust the user's judgment, because if you think about like how you use libraries, right? You're handing your object out to some library call. You don't really know like how it's gonna, dissect the object graph it holds on. It may decide to hold on to some fields. So that's what they discovered, that when they actually are doing a GC, they do need to have GC discover like, I still have these leaks from arena that are pointed to by the normal GC heap. In which case they'd have to promote those objects out of the arenas and back onto normal GC heap. And that just, in the end, it didn't really give us enough benefit for our management to adjust the cost of putting this feature in our framework. So I think
Awesome.
the point that I want to convey here is that it's difficult to guarantee that when you say these objects should be gone, that they're really gone. We also talked about, when we were thinking about the arena feature, we also talked about like, why don't we just have like a diagnostics mode that folks can turn on? So like, before I put this in production, I'm gonna run this in my test environment with this diagnostics mode. So it'll tell me what objects got leaked. But then, when you put something on production, people always discover something that they never discovered on test environment, runs. So that's not foolproof. So in the end, we decided not to take this feature. This is something that I might take a look at again in the future, because it definitely has this merit.
Okay, and yet another question going back to barriers. A question from Chad. Speaking of barriers, how difficult it was to support running garbage collector on ARM architecture, which is completely different from x86.
Oh. Yeah. So we added the ARM64 support, I think, in either 2.x or 3.0. I don't really remember now. But basically, we actually do much work on our team. So we had an engineer from Qualcomm at the time. He's actually on our team now. So he was working at Qualcomm. He's the one that did most of our ARM64, the barrier work. So he ported all the current ones to ARM64. And, basic idea there is that you have to add a bunch of memory barriers here and there, because, on x64, of course, we're pretty, I guess depending on how you look at it, but we didn't need to spend as much effort. To be perfectly honest, we still had to spend a quite significant amount of effort just to get things right for barriers and some other primitives that we have in the runtime, even on x64, such a strict memory model. But on ARM64, it was mostly done by him, and he's, I'm pretty sure that he knew about the memory barrier at least better than many of us at the time, on our team. Of course, now, many people on our team have been looking into ARM architecture. So the memory model there is, I would say, definitely requires some thoughts. Like I actually fixed a couple bugs in the suspension logic for ARM64 and .NET 5. Not that we actually observed the repro of the bugs I fixed. It's purely just based on that's the reason about how things would work on ARM64, and this is what the extra check that we have, the extra memory barrier that we have to put there for ARM64. So it was really just from that perspective, but I didn't make those fixes. So yeah, that was the story with our ARM64 porting work.
And I have a non-technical question, actually. Over this talk also, you always, not always, but often mention that, yeah, I did something and I did something, and there was a rumor for a long time that it's only you who maintain the garbage collection. So what is the truth now? So what is the garbage collection team? How many people are there?
So for the longest time, that was the case. So I've been working on the GC for probably 16 years, I think. Yeah, because when I went to Prague last year, I said I worked on GC for 15 years, so 16 years now. So I would say for the probably for at least 13 of those, I was the dev for GC. Of course, during that 13 years, the later part of the 13 years, I was both the architect and the dev for GC. I mean, when the previous, my predecessor retired. So it was true. But recently, fortunately, our runtime team gave me more resources. So now we have a team of, still a very small team, nothing compared to the Java folks. We have a team of, I would say, 3 to 4 people. The reason why I don't say 4 is because the 4th person, he's not full-time on GC, but he does spend some chunk of his time on GC. He mostly works on the infrastructure part. So the full-time people, there's 3 of us, including myself. That's a true story.
And what about external contributions? You mentioned that one by Dan, but were there any other examples of like external contributors?
Well, the ARM64, the person who did the ARM64 support for us, I would also consider him as another significant contributor to the GC, because he did make GC work, sort of add all the all the places that required extra memory barriers. He did do that, and of course he did the write barrier work. I mean, write barrier, you could say like it's a VM side thing. The code does live on the VM side, but it is obviously heavily used by the GC. So he's another contributor, significant contributor. We also had some Intel folks that did some tuning work for the GC. So we had mostly folks. I would say Dan is the only person who didn't do this in a professional context, right? Okay. Out of our significant external contributors, yeah. Because this is not his day job, right? The other folks they did this as part of their job, but Dan, okay. He's just, yeah. I mean, he's very passionate about perf, and yeah.
Yeah. So I think we are almost out of time, so I must say thank you for you, Maoni. Definitely great work, keep up, and even with the small team, you are doing a great work for the .NET world in the same. And thanks, Conrad, for joining us.
Of course, my pleasure. Thank you.